In this example, we're going to solve this separable differential equation, and we can use our initial condition here in order to find its particular solution. Okay, well I know if it's separable, I need to get the x's with the dx on one side and the y's with the dy on the other side. So let's go ahead and transition this negative xy prime to the right to make it positive, and then let's go ahead and switch both sides of the equation using our symmetric property of equality. So ultimately I'm going to end up with xy prime equals y times the natural log of x. And when we go ahead and change our y prime to dy dx, we can get a good idea of where our x's need to go and our y's need to go. So let's divide both sides of our equation by xy, and the reason we're going to do this is because since the dy is up here in the numerator, I know my y's need to be on this side, and my dx, I'll be multiplying both sides by that, so that'll end up on the right side. So the x's here will cancel, getting my y's with my dy, and my y's here will cancel, getting all my x's together. And then when I multiply both sides by dx's, well, those cancel, and I have kind of a mess here, but let's go ahead and clean it up. 1 over y dy equals the natural log of x over x dx. So that cleaned up fairly well, and it looks like I'm ready now to integrate both sides of my equation. And the left side will be pretty straightforward. The integral of 1 over y is the natural log of the absolute value of y. The right side, however, looks like I need to use a u substitution. So let's go ahead and say u is the natural log of x. So du equals 1 over x dx, which means that dx equals x times du. Okay, so let's go ahead and kind of put this all together. The ln of x was our u, so u over x times the dx was our x times du, and that's nice because it looks like those x's will just cancel. So our natural log of the absolute value of y will be the integral of u du. Well, the integral of u is u squared over 2 plus c. So let's go ahead and put our u back in, so the natural log of x. So that will give me now the natural log of x squared over 2 plus c. Well, alright, it looks like I'm ready to solve for c by plugging in the values from my initial condition. So my initial condition said that y of e squared equals 1. So e squared should be my x value, and 1 should be my y value. So let's go ahead and plug those in. So if y is 1, then the natural log of 1 is, well, 0. Okay? So that equals, when I put e squared in for x, this is going to be the natural log of e squared over 2 plus c. Well, the e squared, and it's a natural log, so I can bring this 2 out front, and the natural log of e is 1, and 2 times 1 is 2, so all of this just goes to 2. 2 squared is 4. 4 divided by 2 is 2 plus c. Okie dokie, so c equals negative 2, which makes a pretty nice value. So let's go ahead and put all this together now. So we know the natural log of y equals, and then we have this ln of x squared over 2 minus 2. So we could isolate this y and write it in explicit form by taking both sides of our equation and raising them as powers of e. So it looks like y will be e to the power of, and then all of this is our exponent of e. So it's going to be the natural log of x squared over 2 minus 2. So here is our particular solution given that initial condition that we had, and it's written in explicit form with y equals.